Hi everyone, welcome to the PCD of today's Educational Codeforces Round 174. I am Pradyumn and today we'll discuss the first four problems A to D. And uh, so yeah, but before that, I would like to tell you about the all new CP31 sheet by TLE Eliminators. For those who are not aware, this sheet consists of 31 handpicked problems in each rating from 800 to 1900, carefully chosen so that each problem teaches a unique idea. Our sheet has now been upgraded with a new interface. As you can see, automatically syncing your process with your Codeforces account. So you can just connect your account and it will sync your process, right? There is also a leaderboard section, so where you can like see your friends and your own problem solved and compare, and you can compete with your friends as well. Added to this, every week 7 to 8 video solutions will be uploaded. So no more wasting time searching for the right problems. The link to the sheet is in the description of this video. So yeah, let's get started. Okay, so I'll open the code forces. Just a minute. Yeah, so this was today's contest. And the first problem was, it is called was there an array? For an array of integers a1, a2 up to an, we define its equality characteristic as the array b2, b3 up to bn minus 1, where bi is equal to 1 if the ith element of the array is equal to both of its neighbors. So if a2 is equal to a1 and a3, then b2 will be equal to 1. Otherwise, b2 will be equal to 0. Okay. For example, the array 1, 2, 2, 2, 3, 3, and 4, 4, 4, 4 has the equality characteristic 0, 1, 0, 0, 0, 0, 1, 1. So basically, what you do is for each index from 2 to n minus 1, you just compare both of its neighbors, and if it is equal to both of its neighbors, then it will be 1. So since this 2 is not equal to this left neighbor, the first element, that is b2, is not equal to 1, it is equal to 0. You are given the array b2 to bn minus 1. Your task is to determine whether there exists such an array A for which the given array is the equality characteristic. So basically, you have been given the array B, and you have to figure out that can there be any array A, that can there be any array A such that this is the equality characteristic. Okay, so that's the first problem. So yeah, let's try to think about it for just a minute. So let's look at the samples, or let's just look at this array only. So let's say this was our input, then of course the answer will be yes, because this is one of the possible arrays that we can make, right? But okay, let's see how to prove that. Like let's try to derive the answer by ourselves. So 0 1 0 0 0 0 1 1. So okay, 0 1 0 0 0 0 1 1. Right. So this is B2, this is B3, and up to this is B of 9, right? Since there are 8 elements. Is my voice audible? Okay. Right. So B2 to B9, right? Now, let's say we have to make the array A. So array A will contain 10 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So the first element, let's say, first element can be anything. So let's keep it 1. All right. Now, what we know is that this B2 is equal to 0. Right? So what that means is that whatever the element is here, either it is not equal to the forward one or it is not equal to the backward one, right? So let's just assume that it is not equal to the backward one. So let's say it is 2. Because why am I doing that? Because the B3 says that these two actually are equal. Like because B3 is 1, that means that 3 is equal to 4. Like the index 3 is equal to index 4, and also the index 3 is equal to index 2. right? So actually, better way to explain this would be like, just look at all the ones. Look at all the ones. This one, and this one. Okay. So what does this one say? This one says that, okay, this one says that these three are equal, right? A2, A3, and A4 are equal. Then this one, that B8 says that this is 9, right? So 8. So these three are equal. And B9 says that these three, like this, and this, these three are equal. So I'll just do this, right? So actually here there is no contradiction. So what we can just do is just make all these four equal, all these four equal, all these three equal, I mean, and just like make all the others unequal. Okay. So let's say I make them like this. So one, we need to make these three equal. So 2, 2, 2. Then let's say we have 3, then we have 4, then we have 5, 5, 5, and 5. And now as you can see that no zeros are actually like contradicting, because wherever I did not draw this curve, so there is a zero there. But in that case, like, there is no contradiction, because let's say on B2 we have 0. So this is the second element. So I'll just number this 1, 2, 3, 4, 7, 8, 9, 10. Yeah, so on the second one we have the left side as like not equal to the second index. So 1 is not equal to 2. So therefore this 0 is not contradicted. So this 0 is satisfied. Then all the ones are actually satisfied. So that's what we have ensured, right? And then uh, this B4 should be 0. So that means that this fourth element should not be equal to either third or fifth element. So it is not equal to fifth element, right? So as we can see that all of the zeros are satisfied. So that's one way to solve this problem. Like, we can just look at all the ones and ensure that they are satisfied. Okay. And then we can just check for the zeros. We can just check for the zeros that, okay, is like, are they satisfied or not. So first of all, we'll just put equal numbers on these ones, and for all these zeros we'll check that are they satisfied or not. So that is one way. But there is another way actually. That is, look at the samples. Like, okay, so let's think that when would there be a contradiction? Like, answer no, how can that be? Like, when you are reading this problem, you might think that how can the answer be no? Like, why can't I just create an array like this? That since the first, like, I just look at all the ones, and wherever there is equal, I'll just keep them equal, and others non-equal. So how can the answer be no? So for that, let's look at the samples. So the third sample, as you can see, it, has the answer no. So why that is? Let's think about that. Okay. So the array is 0, 1, 0, 1, 1, 0, 0, 1. 0, 1, 0, 1, 1, 0, 0, 1. Okay. Yeah. So let's try to do the same thing that we did above, right? So I'll just make a new array. 1, 2, 3, 4, 7, 8, 9, 10. 1, 2. All right. So here I need that the third element should be equal to, like, the third element is here is 1, right? So these three should be equal. Then this 1, 1. So 2, 3, 4, 5, 6, 7, 8, and 9. So on third we are equal. On fifth we are also equal. So fifth is equal to fourth and sixth. Then six is equal to 5 and 7. So 6 and 7. And then 9 we have 8, 9, and 10. Right? But now the problem here is that on this fourth one, it is saying that either one of these sides should not be equal. Right? But as we can see that all of these have become equal. So definitely we cannot, like, this is a contradiction, right? Because these two ones say that 2, 3, 4 has to be equal and 4, 5, 6 has to be equal. But this 0 between them says that this 4 should not be equal to either 3 or 5. So that's a contradiction. We cannot actually satisfy that condition. So in general, if you can see, in general, if we have any 101 in the B array, if B has some numbers and then it has 101 and then it has some numbers, then what does that mean? Then that, let's say this is the index 5, this is 6 and this is 7. So this 1 means that 4 should be equal to 4, 5, 6, 7 and 8. So here this one wants that 4, 5 and 6 should be equal, and this 7 wants that 6, 7, 8 should be equal. But that means that all 5 of these are equal. So definitely this 0 will not be satisfied. Okay. So that's why this is a contradiction. So my point is that if anywhere you see 101, like if anywhere in the array B you see a 101 happening, then definitely we can say that you are it is not like it is not possible to construct the array A, and otherwise you can just construct the array like I told you. So wherever there are ones, just try to satisfy them, and automatically zeros will be satisfied, other than the case where there is a 101. So the final solution is to just iterate through the array B and check if there is a 101 or not. So if there is a 101 in the array, then the answer is no. Otherwise, the answer is yes. So why actually otherwise the answer is yes? Because let's say if 101 is not there, let's say 1001 is there, then what does that mean? That okay, um, that these three are equal, and so this is the one, and here is the one. So these three are equal, but it says nothing about these two. So these two can be different. That's why there is no contradiction for 100. Okay, and if there is a 1 1, then also no contradictions, because that this is one, this is one. So these two should be equal, and this one says that these two should be equal. So all four have to be equal. So that's like that's no problem. So the only contradiction happens in 101. That's why we can just iterate through the array B and check if there is some 101 or not in the array. Okay. So yeah, that is the final solution. So is it clear to everyone, the logic? The time velocity of this would be just O of n, because we are just iterating through the array like once. We have to just make a loop of n and then check if. So basically, what we'll do is b's of array n minus 2, right? B's of size n minus 2. So we'll iterate from, let's say this is b. So first we'll have a pointer starting at 0. So let's say this is I. Then we'll check if bi is equal to 1, bi plus 1 equal to 0, and bi plus 2 equal to 1. So we'll check this thing for all I here, 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 here. So up to here, the last three elements. So basically, this since the size is n minus 2, the size of b is n minus 2. So we'll iterate from 0 to n minus 4, or basically 1 to n minus 4 in one indexing. So like in one indexing, we'll iterate from 1 to n minus 4, or in zero indexing, we'll iterate from 0 to n minus 3. Okay, so that's the thing. So I think it is clear to all. I'll just show you the code. Okay, so this is the code. Int n, scene n, and I just input the array. I mean, this is a macro actually used for making an input in the array. So IA. So this is What it does is it declares an array A of n minus 2 size and then inputs it. Okay. Now I just iterate from I equal to 0, I less than n minus 4, I plus plus. So if a of I equal to 1, a of I plus 1 equal to 0, and a of I plus 2 equal to 1, then I just print no and return. Return means, so this void solve function will be returned. And otherwise, like if this for loop didn't return, then that means that there is no 101. So I'll just print yes. So this is a O of n complexity. All right. So I think it should be clear. So let's move on to the next problem. Codeforces seems to not respond. Just a minute. Yeah. Okay, so you are given a table of n rows and n columns. Initially, the cell at the ith row and jth column has color aij. So there's a table of n rows and n columns, and each cell has a color of aij. Let's say that two cells are strangers if they don't share a side. Strangers are allowed to touch with corners. So, okay, let's say that the set of these cells is a set of strangers if all pair of cells in the set are strangers. Sets with no more than one cell are sets of strangers by definition. So what they say is that we have a board of size n by m. Okay, so I'll just draw a board or a table. So whatever. So this is a table of size n by m, where n is equal to 4 and m is equal to 6. And so basically what they're saying is that these two cells are not strangers because they share a side. So if two cells share a side, then they are neighbors. And if they don't share a side, let's say this and this, then these two cells are not strangers. I mean, they are strangers. So if they are strangers if they don't share a side. So these two cells are not strangers, and these two are strangers. All right. And also these two are also strangers because they don't share a side. They can share a corner, that's okay. All right. Now what they are saying is they have defined a set of strangers. Set of strangers, what does it mean? It means that it is a set of points, a set of cells. So let's say this, this, and this. So this set is actually a set of strangers because no two cells in this, no pair of cells are non-strangers. So they don't, no two cells share a side. So let's say these two, let's say if this was set, then this is not a set of strangers because these two cells share a side, so they are not strangers. So this set is actually not stranger, but this set is a stranger set. Okay. In one step, you can choose any set of strangers such that all the cells in it have the same color and paint them all in some other color. You can choose the resulting color. What is the minimum number of steps you need to make the whole table the same color? Okay. So in one operation, what we can do is we can choose any set such that it is stranger and such that all have the same color. Okay. Right. So and then we can paint all of them in some other color. So that is one step. So I'll just use a test case to explain that. So we have 1 2 1, 2 3 2, and 1 3 1. So we have 1 2 1, 2 3 2, and 1 3 1. So what we can do is let's say we choose these four cells and convert them into three. So we can do that because they are strangers. All of the pairs are strangers in the set, and all of they have the same color. All of them have the same color. So we can just change them to three. So I am choosing them that let's make them three. Okay. I'll tell you why in a second, but let's just do that right now. So three, three, and three, and three. So that's one step. And then we can choose these two, two, and two. Why we can do that? Because uh, these two are not strange, they are strangers, right? So we can choose these three twos and convert them into a three. So that's how the whole grid has been converted into the same color. So we just took two steps, and that therefore two is the final answer, right? So we want to just print that for any grid, what is the minimum number of operations that we have to make, right? Now there is one observation here that the definition of a stranger set is actually very helpful to us. Why? Basically, just kind of imagine a chessboard. Okay, imagine a chessboard where, let's say this is we have a 4 by 4 chessboard. So this one will be black, this one will be black. So like half of them are white and half are black, right? So this one, and this one and this one. So in this chessboard, if you can see that all the black pieces actually they are strangers. Like if I just choose all of the black cells, they are all strangers. And if I choose all the white cells, they are also all strangers. Like these two sets both are strangers among themselves, right? So actually, this is actually one very good observation that for a given color, we don't actually have to do an operation more than two times. So I'll move on to that. But before someone is telling me to explain the fourth test case. Okay, so I explain the fourth test case. We have 1422. 1422, 1435, 6635. Okay, so what we'll do is first we will just let me think for a minute. 4, 3, 5, 3, 2, 6. Okay, so I think 10 should be the answer. Yeah, so let's just try to make all of them as 6. Okay, so okay, are you understanding that how can we do it in 10 operations? I think that should be obvious, right? Because we can just choose them individually. So we can choose all of these 10 vertices individually or 10 cells individually and change them to 6. So that's how we can do it in 10 operations. So are you asking me that why can't we do it in less than 10 operations or what? Like, is that what you're asking me? That why can't we do it in less than 10 operations? I mean, in 10 operations, it is pretty clear that how can we do it? We can just take all of these cells such that they are not 6. So there are 10 cells, and just we can just take them individually and change them to 6. So we can do that in 10 operations, right? That's why the answer is 10. And I'll tell you why we cannot do it in less than 10 operations. Okay. So for that I'll have to explain how what is the algorithm here. All right. Okay. So in the question, if you don't have the clarity, then you can just reread the question and or maybe rewatch the recording of me explaining the question. And anyways, so all right. So what I was saying is, just imagine a chessboard. where half the cells are black, right? And half are white, right? So if you see that all of the black cells among themselves are actually strangers. Like what I'm saying is, if you choose all of the black cells, then that set doesn't have any edge. Like no two cells in that set share an edge. Okay, so that's why that is a stranger set. And if you have a set of white cells, okay, then also it won't share any edge. So actually, we can use this fact in a very clever way. How we can use this fact? We can just do something like, basically what we'll do is, the input that we have been given. Let's say this input 1 2 1 2 3 2 and 1 3 1. 1 2 1 2 3 2 and 1 3 1. Okay. So let's just imagine this as a chessboard. Okay. So let's say in my chessboard, either cells are red or green. So this is red, this is red, this is red, this is red, and this is red. Okay. And for green, this is green, this is green, this is green, and this is green. All right. So now what you can observe is what I just told you, that if you choose any subset of green cells, then definitely they will be strangers. So, and also if you choose any subset of red cells, then it will be strangers. So if you just want to convert the white, like if you want to convert the number 1, let's say, so let's say you want to convert all the numbers into some number k, like you have to convert all the numbers into the final number, right? You have to convert all of them into some final number k. So let's say you want to convert them into k. So 1 you have to convert into k, 2 to k, 3 to k, right? So uh, in how many moves can you actually convert all the ones into k? Just tell me that. You can actually use just one move, because all of the ones are on red cells. Like this one, this one, this one, and this one. They are all on red cells. So we can actually just choose all the 4 ones. Why? Because they are on red cells. So we'll convert them into k. Now let's say we want to convert this 2 into k. So to convert this 2 into k, what we can just do is select all of these 2, because all 2's are on green cells. So we'll convert them into k, right? And the remaining we have 3. So 3 actually lies both on red and green, right? So actually we cannot select both red and green in one move, because like it is pretty obvious. Why? Because they share an edge. So definitely we would have to spend 2 moves. First selecting this edge, first selecting this cell and converting it into K, and then selecting this cell and converting it into K. So that's how we have converted all of them into K. But actually that is pretty stupid, right? That why are you converting it all into K? What we can just do is convert convert all of the numbers into some number which is already there in the matrix. Like basically, if I had converted it into 3, let's suppose, say, um, basically for one I took one move to convert it into K. For 2, also I took one move to convert it into K. But for 3, I took 2 moves to convert it into K. So in 4 moves, I can convert all of them into any number I want. But I what should I convert them into? Actually, I should just convert them into a 3, right? Like if I convert them into a 3, then I would not have to touch these 2 numbers. Like they are already 3, right? So I can just convert all the ones into a 3 in one move, and all the twos into a 3 in one move. So in total I just need 2 moves to convert all of them into 3, right? So that's what the algorithm is, that you can just count that for each number how many moves you need to convert it into some other number. And how would you do that? You can actually just check that are all the ones, like let's say for one I'm checking, then just check that are all the ones on same color, are or not. So or are they in different color, like that. But that's one way. And another way what you can do is you can just figure out that are they sharing an edge. Okay, actually there is one mistake in this logic. Like let's say that a one is here and a one is here, and the colors are like this: red, 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 and red, red, and green is like this. So green, 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 and green, green. So as you can see that these two ones are on the different colors, but actually um, they can be selected in one move, right? They can be changed in one move. So the condition actually is that ones should not like share an edge. If ones share an edge, then definitely we cannot do them in one move. Okay, so see, for every number, what you can just do is check that do they share any edge. I think I'm not very clear, so I'll explain using a test case. Okay, 1 2 1 2 3 2 1 1 3 1. So as you can see here, that there are no two ones such that they share an edge, right? That's why we can actually do them all in just one move. We can convert them into one in one move. Why? Because they don't share an edge. So my claim is that no two ones share an edge. That's why we can convert them in one move, right? So that's why we can convert them in one move. But like look at the threes. So these threes actually share an edge, but there is one pair, like, but basically three share an edge. Threes share an edge. So I can do them or convert them in two moves. Like my point is that if there are no two ones such that they share an edge, then obviously you can just select all of them and convert them. But suppose there is a pair such that it shares an edge, then we can always do it in two moves. That's my claim. And how do we do that? Like, let's say even all of them are same. Let's say 1 1 1 1 1 1 and 1 1 2. Okay. And let's say we want to convert all of these numbers into 2. Into 2, we want to convert all these numbers. So actually these numbers share a pair. Like these two numbers share an edge. So they are not strangers. Then these two are not strangers. These two are not strangers. These two are not strangers. So there are so many not strangers pair, not non-stranger pairs. So definitely we cannot do it in one move. Like we cannot actually select this entire set and convert them because they are not strangers. But my claim is that no matter what the configuration is, you can always do it in two moves. How? Just first choose the red ones. Like this is the red and green positions. So first just choose the red ones and then just choose the green ones. So you can always do it in two moves. That's my claim. All right. So this is the proof of my claim that if for a number no two numbers share an edge, then you can always do it in one move, and otherwise you can do it in two moves. So now we just need to decide that to which color should we change all the numbers to. So in this example, we changed all of them to 3, right? So how to choose that? to which one to change. So someone says maximum occurring one. That is actually failing in this test case only. Like if we convert all of these numbers into the maximum occurring. So in this test case, the maximum occurring is number one, right? In this test case, one is the maximum occurring, right? So actually we saw that one takes one move to convert, two takes one move to convert, and three takes one move to convert. So if you convert two and three into one, sorry, three takes two moves to convert because three has an edge, three has a common edge. So since three takes one move to convert, I mean two moves to convert, then if you try to convert both these two and three into one, then it will take three moves because two will take one move and three will take two moves. But if you convert one and two into three, then it will only take two moves. So you should convert it into the number which takes two moves. Like if there is a number which takes two moves to convert, then definitely you should convert it into that. Okay, that's my point. So just 1 minute. Yeah. So what I was saying is, if there is a number which takes two moves, then just convert all the others into that number. Okay. So now what remains is that how to count, like that how to check that for let's say one, that in this test case these two threes were adjacent. So three would take two moves, but all of the ones are not adjacent. So they would take only one move. So how do you actually check that which number has which type? So which number takes one move and which number takes two moves? How do we efficiently calculate that? So I'll move on to that part, but before, if someone has doubt right now, I'll take. So which two elements are adjacent? All numbers should be connected to that. Yes, correct. So now just we have to figure out that how to classify the numbers into two categories. The type 1 category is the one which takes one move, and type 2 category is the one which takes two moves. So how do we categorize them? Basically we know that all the numbers which are adjacent to themselves, they are in type 2, and all the other numbers are in type 1. So what you can do is just iterate over every cell. Okay. So if you iterate over if you iterate over these cells, let's say you are at this cell. Okay, just check all of its four neighbors. Okay, all of its four neighbors, just check. And if you find any equal cell, let's say that here there is a 2. Okay, here there's a 2, and here there's a 1, here there's a 3, here there's a 1, and here there's a 2. So since these two are same, then what you can say is that 2 is of type 2. 2 is of type 2 because these two 2's are adjacent. So just iterate over all these cells. So let's say you are at this cell, then just iterate over all the neighbors of that cell. So there are at most four neighbors of each cell. There are at most four neighbors, and just iterate over them. And if they are equal, like if they are equal to this cell, then definitely that number is of type 2. And otherwise, all the other numbers are of type 1. So that's how you can classify them. And if there is at least one type 2 number, then just convert all the other numbers to that number. And if all are type 1 numbers, then it doesn't matter, just convert into one of them. Then it will just take like num of numbers minus 1. So I just dry run my method on this test case. So 1 2 1 2 3 2 and 1 3 1. So I am like maintaining an array called type. type array. Okay. So 1, 2, and 3. Initially, all of them are 0. 0 means that they are not present in my array or my matrix. So because not all of the numbers are present in the matrix, right? So initially I have made an array which contains all zeros. Now I iterate through the matrix. So first I am here. So 1. Since I am at 1, so that means that 1 is there in my array. So I'll make it type 1. Like type 1 means it is present there and it doesn't have any pairs. Now I'll just check both of its neighbors and they both are distinct. So I won't do anything. Now I will go to this second number 2. Now since I am at 2, I will change the type 2, like type of 2 to be 1. 1 means present, and then I'll check all of its neighbors. So this neighbor, and this neighbor. All three are distinct, so I won't do anything. So I'll keep doing this, right? So let's say I go to this 1 now. So the type of 1 will change to 1. So it is already 1. Then this 2, then this 3. So 3 means, so let's say I am at 3. So the type of 3 becomes 1. Okay. And then I'll just check this upper element, the side, and this lower. Now, as you can see that this lower element is actually equal. So I'll change the type of this 3 to 2. Earlier it was 1, now it is 2. Okay. And so whenever I find a pair which is matching, then I'll just change it to 2. And I will never change a 2 to a 1. I'll always change a 0 to a 1 if I find that number, but I'll never change a 2 to a 1 because I have already found a pair. So now I have finally this array. Like I'll iterate through the rest of the matrix as well, but it won't change the array. So final array will be this only, that 1, 1, 2. The type array will be 1, 1, 2. So basically now the final answer, what would it be? It is just, I have to convert this. So basically it is just the sum of 1 and 1. Like I'm converting this 1 into 3 and 2 into 3. So the answer is 1 plus 1. Or what you can say is, in general, the answer is just sum of the array minus max element. Why? Because let's say we have some other array. Let's say 1, 2, 3, 4, 5. We have 5 numbers. And let's say we have a 3, or not a 3. So 1 is of type 2, 2 is of type 1. 3 is not there in the array, so 3 is of type 0. Then 4 is of type 1 and 5 is of type 2. So here the maximum element is 2. So what we can just do is convert all of the numbers into 1. Okay. So converting 2 into 1 will take 1 move. Converting 4 into 1 will take 1 move. And converting 5 into 1 will take 2 moves. So it is 4. So as you can observe that the answer is just sum of the elements minus the max element. Alright. Someone asking what is the condition for checking adjacency? Okay, so in matrices, if you are iterating, so let's say you have a 2D array called A. So A is an 2D array of size n by n, right? Then let's say you are at I comma j. Okay. So this is I equal to 0. This is I equal to 1. This is I equal to 2. And this column is j equal to 0, j equal to 1, j equal to 2, and j equal to 3. So if suppose you are at I comma j, like you are iterating, you have two for loops, I equal to 0, 0 to n minus 1, and j equal to 0 to n minus 1. So let's say you are at ij, then the adjacent to aij would be a of I minus 1j, then a of I plus 1j, a of I comma j minus 1, and a of I comma j plus 1. Like these four cells, they would be adjacent. Like I'm assuming that they all are valid. Like for example, if I equal to 0, then this I minus 1 would not be valid. So this would not be a neighbor. And suppose if j equal to 0, then this a of I comma j minus 1 would not be valid. But basically in general, I can say that aij ke neighbors are these four neighbors. All right. So while you are iterating over the matrix, you can just check that is aij equal to a of I minus 1j, is aij equal to a of I plus 1j, and so on. And if any one of them is true, then you can just mark aij as type 2. Got it? Okay, so let's just move on to the code now. All right, so we have the input nm, c in nm, and I make a 2D array a of nm, and this for loop for int I equal to 0, I less than I plus plus, for int j equal to 0, j less than j plus plus, and c in aij, a of I comma j, right? Then I have like this is actually a nice trick that you can use like to iterate over all the neighbors. I'll explain what that is. So I have a vector called type of size n into m plus 1 because the numbers are till n into m. If you can see that the constraints of aij were up to n into m. So I'm defining this type, and initially all of them are 0. Now for int I equal to 0 is an I plus plus, for int j equal to 0 is an j plus plus. So I'm iterating over all these cells, and I'm doing type of aij equal to 1. Like basically, if it was 0, then I'm changing it to 1. But I'm also taking the max, like max of type aij comma 1, because if it was already 2, like if the type of aij was 2, then I wouldn't want to change that to 1. So I'm taking max of 2 comma 1. Okay. Now I'll just loop through the four directions. So for adjacency. So if I'm at aij, then I want a I minus 1j, a I plus 1j, a I comma j minus 1, a comma j plus 1. I want to check all these four. So I loop through the four directions in this for loop. So here actually I use these two arrays, dx and dy. So dx means change in x, right? So so basically, let's say k equal to 0 to k equal to 3, right? So let's say k equal to 0. So in the first iteration, what will happen? X equals to I plus dx of k and y equal to j plus dy of k. So if k equal to 0, then dx of 0 is 1 and dy of 0 is 0. So basically, in first iteration, it will happen that I plus 1 and j. So in the first iteration, it will check for I plus 1 and j. So x equals I plus 1 and y equals j. And I also have a function called is valid. That is a pair of coordinates valid. Like is xy valid? Valid means that is it in the grid? So for that, x has to be greater than equal to 0, less than n, and y has to be greater than equal to 0 and y less than n, right? So I just loop through all the four directions and I find the new x and y. So if x and y is valid, that is in the grid, and a of x equal a of xy equal to a of ij, then that means the type of a of ij equals to 2. I'll mark a of ij as type 2 because there is like adjacency. Two adjacent of like aij have the same number. Can we just check down and right? Yes, you can do that because we have already, yeah, that is correct. I think you know why, because you have asked me the question. But yes, you can do that. Just check down and right. Okay, so I just do this. So now I have the type array and just print accumulate. Accumulate just prints the sum of type dot begin type dot end minus the max element. Okay, someone asking why down and right only? Because that is sufficient. Because you have let's say you have a pair. Let's say there is a one here and a one here, and you want to detect that one is of type 2. So when you reach here, okay, then if you just check down and right, then you will be able to successfully detect that there is a pair here. And let's say, but then you would ask that what if it was like this, that one ke left mein there is a one. Then you should think that when you are iterating over this, then you will detect this 1 1 pair. Then you can only select check for down and left also. Yes, that is also correct. You can check for down and left, down and right, up and left, or up and right. So all of these four combinations work. 4n square also AC. Yes, 4n square is accepted because the constraints are like not very high. So n into m is still 5 into 10 raised to the power 5. So 4 into this number is just 2 and 2e6. 2 into 10 raised to the power 6. So that is passing comfortably under 10 to the power 8. Like whatever you use 10 to the power 8 or 5 into 10 to the power 7, it is definitely less than that in 1 second. So that's why it is passing. Right. So anyways, so I was just telling you that yeah, actually this is very redundant that if max element is 1, then the answer is sum minus 1. Otherwise, the max element is 2, so the answer is sum minus 2. So actually, I could have just written C out sum minus max element, right? So yeah, that's the solution. So do you have any doubt in any part? Okay, so I'll just move on to the problem C. Beautiful sequence. Let's call an integer sequence beautiful if the following condition hold. Its length is at least 3. For every element except the first one, there is an element to the left less than it. And for every element except the last one, there is an element to the right larger than it. So they have defined a beautiful sequence. So what is a beautiful sequence? That it has length at least 3. And for every element, there's an element less than that to the left of it. Okay, so let's say 1 4 2 4 7 is beautiful, 1 2 4 it is beautiful, but 1 2 is not beautiful because it has length less than 3. 2 2 4 is not beautiful because this middle wala 2 doesn't have any element that is less than that to the left of it. And this is not beautiful because this 5 doesn't have any element which is greater than that to the right of it. And also this 3 also doesn't, okay, this 3 has, but this 5 doesn't have any element to the right of it which is greater than 5. Okay, so you are given an integer array A of size n where every element is one or from 1 to 3. Your task is to calculate the number of beautiful subsequences in the array A. Since the answer is large, print modulo 9924353. Okay, so actually this problem is very like nice to implement. The logic is pretty simple, but okay, I'll just tell you. All right. So first of all, let's analyze the beautiful sequence. Like they have defined a beautiful sequence. Let's simplify it. The conditions are pretty like they are somewhat complicated. So let us simplify them. Okay. So what they're saying is that a beautiful sequence. What is that? Beautiful sequence is that for every element, one condition is that n greater than or equal to 3. That is one condition. And another condition is that for every element except the first one, that is all of these elements, let's say AI. So AI, for every AI, there should be an AJ, okay, such that AJ is less than AI. So for every AI, there should be an AJ such that AJ is so left of AI. So J is less than I and AJ is less than AI. And also for every AI from 1 to n minus 1, there should be a J such that um, J is great. So this is one condition that for every element except the first one, let's say AI, there should be an element to the left of it, such which is less than AI, right? And another condition is that For every element except the last one, let's say AI, there should be an integer aj to the right of it which is greater. So AI should be less than aj. So both of the so there are two conditions and both have to satisfy in order to call the subsequence beautiful. So there are two conditions that have to satisfy. Now let us think about it. Okay, just think that just think about the first condition. Okay, so we have this condition for all the numbers which are not the first one. So except the first one, we have this condition for all the numbers, all of these numbers. That let's say there's a number here x. So there has to be a number which is less than x to the left of it. Okay. So let's say y is less than x, and it is here. But now for this y also, it is the condition. So let's say there's a z here, which is less than y. So z is less than y. So for z also, we have a condition that okay, the element here, suppose w should be less than z, right? So what you actually see is the order is kind of that this w is actually the minimum. Okay. So my claim is that w cannot be in between. Like let's say the minimum element is mi. Yes, the min element is mi and the max element is ma. Okay. So the my claim is that min element should be at the starting and max element should be at the end. Why is that? Let's prove it. Let's say that min element was not at the starting. Let's say that min element was somewhere in between. Let's say here. Then definitely that condition will not be satisfied. Like because for this number, there is no number to the left of it which is less than the number. Because this is the minimum, right? There are no numbers less than the minimum. So if minimum is at the center, like somewhere else, then definitely it is not satisfied that um, there's a number less than minimum. So therefore minimum has to be at the left one. So if I give an example, let's say there's a 1 here and 1 is the minimum. So you cannot place anything here because if you place 2 or 3 here, then the conditions are not satisfied that there should be a element less than 1 to the left. And you cannot actually place 1 as 1 also. You cannot place 1 also because 1 is actually not less than 1. So you have to place 0. You have to place 0 here, either here or here. But in that case, the min element is 0, not 1. So my point is that minimum element should be in the beginning and the maximum element should be in the end, right? And in the middle, the elements x, like all the elements, let's say x element, they have to be between minimum and maximum. Minimum less than x, less than maximum. Why that is the case? Because let's say if it was equal to the maximum, let's say, like if there was a maximum which was here. Just 1 minute. Uh, why does this happen every time? Just a minute. Yeah, so I am saying that suppose the minimum was here as well, then the condition for that element would not be satisfied. That to the left of it, there should be some element less than minimum. But that is not the case because it is the smallest element. All right. So therefore, the minimum should be at the beginning, maximum at the end, and the middle elements, all of them should be between minimum and maximum. So the array actually what we have been given every element is from 1 to 3, right? So definitely, if if this array is a subsequence of our array, like the given array, then our array will also have only elements from 1 to 3. Only 1, 2, and 3 we can fill here, right? And let's say if 2 was the minimum and 3 was the maximum, then what will you fill here? You cannot fill anything here, right? So therefore, 1 has to be the minimum, 3 has to be the maximum, and in middle, all of the elements have to be 2, right? So this is the form. Actually, this is the form that we can have of a beautiful subsequence. Why? Because we want that the minimum element is in the front, maximum element is at the end, and uh, all the elements in between are not equal to the minimum and not equal to the maximum. And since we have only these three elements, 1, 2, and 3, we can only set the minimum as 1, maximum as 3, and in between we can keep 2's. So all the beautiful sequences are actually of the form 1, 2, 2, 2, 2, and so on, and then 3. So if anyone knows rejects, then we can write it as 1, 2 star, and 3. So actually not 2 star, 2, 2 plus, and 3. So anyways, this is not relevant. But yeah, all the subsequences that are beautiful have to be of this form, right? So how do we count that? How do we count them? So to do that, actually, first intuition would be that okay, we choose a 1, we choose a 3, and in between we can choose any number of 2's, right? So let's say we have this array 3, 2, 1, 2, 2, 1, 3. So initial what we want is 1, 3, and in between we want 2's. So let's just choose a 1 and a 3. Okay. And in between we can have as many 2's as we want. So either we can select this 2. So either 1, 2, 3, or we can have 1, 2, and 3, or we can have both 2's 1, 2, 2, 3. So basically the answer is 3, because there is no other pair of 1 and 3 that we can choose, right? This is the only pair that we can choose. Because if we choose, let's say, this one and this 3, then there are no 2's between here. That's the problem. So in general, actually, if we, let's say, there's an array, and if I choose a 1 from here, and if I choose a 3 from here, and there are x 2's in here, like between these 1 and 3, there are x 2's. So tell me, guys, that how many subsequences would there be possible using just these two 1 and 3? Using these two 1 and 3, how many sequences would be possible? So can you guys tell me if there are x 2's here? Someone says 2 raised to power x. Actually, it is 2 raised to power x minus 1. Why? Because basically we can, for every 2, we can, yeah, neglect NC0. Basically, either we select, for every 2, either we select that 2 or we don't select that 2. But actually, we have to select all, like we have to select at least 1, 2, right? So let's say we have 1, 2, 2, 2, and 3. And we have this 1 and 3. So for each two, we can either take it or not take it in a subsequence. So we have 2 to the power 3 ways, but there is one way in which we don't take any 2. So just 1 and 3. So this is not legal. So we have to remove that case. So it is 2 to the power 3 minus 1. Or in general, if we have between 1 and 3, if we have x 2's, then it is 2 to the power x minus 1. Okay. So like O of n square approach, it is clear, I think, that like what we can just do is iterate over 1 and 3, right? Like basically iterate over all the positions of 1, and then iterate over all the positions of 3. So let's say you are at I, like ai is equal to 1. Basically i's position you are at 1, and at jth you are at 3. So just iterate over all of the ij such that I is less than j, and ai is equal to 1, aj equal to 3, and between ij just count the number of 2's, that how many 2's there are, and add to your answer 2 to the power 2 to the power x minus 1, right? But to count the number of 2's, actually what you can do is just make a prefix sum. So between I to j, if you want to count the number of 2's, just make a prefix sum that stores that how many 2's are there in the prefix I. So let's say, for example, if I have the array of 1, 2, 3, 2, 2, 3. So in the prefix, I have no 2, I have 1, 2, I have 1, 2, 2, 3, and 3. So this is the prefix sum of the number of 2's in the prefix, right? So if I want to calculate the number of 2's between, let's say, this 1 and 3, then it is pretty easy that I can just this minus this, right? So in O of 1, I can calculate that. So let's say I iterate over all the positions of I and j such that ai equal to 1 and aj equal to 3. Then I can just do pj minus pi. What is this? The number of 2's. So x. So I'll just do 2 to the power pj minus pi minus 1. And I'll add this to my answer, right? But the thing is that this is too slow. This solution actually too slow. Why? Because it is of n square. And the limit of n is actually up to 2e5. So we cannot actually pass O of n square, right? So we have to think of a faster way. All right. So how do we do that? So just think about how to do that. Okay. So let us take this test case. 1, 2, 3, 2, 1, 3, 2, 2, 3. All right. So we have 1, 2, 3, 2, 1, 3, and 2, 2, 3. So what we want is, we just want the summation of 2 to the power pj minus pi minus 1, right? We just want this from, like, basically j equal to I to n and I equal to 1 to n, or I plus 1 to n, such that a of j equal to, like, we also have to ensure that aj equal to 3 and ai equal to 1, right? So basically this is what we have to find. This is what we have to find, right? And this is double summation, so it can be computed in O of n square trivially, but actually we have to compute it in O of n. So what we can do is just kind of try to simplify it. All right. So to do that, let us take a look at this test case. 1, 2, 3, 2, 1, 3, 3, 2, 3. So how do we figure out the answer to this? Just tell me all the pairs. Just tell me all the possible pairs of I comma j that we can have. So we have these two ones and the three threes we have here. So I just number the positions. The position I'll number. Okay, just a minute. 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right. I will just move this thing. Uh, yeah. So okay. So we have this array, and we need to iterate over all the positions of 1 comma 3. So I comma j, such that ai is equal to 1 and aj equal to 3. So what are the all the positions? So let's say for I equal to 1, what are the positions? They are j equal to 3, j equal to 6, and j equal to 9, right? Then for I equal to 2, we don't have anything because I cannot be equal to 2. So for, next we have I equals to 5. Okay. So I equal to 5, we have j equal to basically 3, 6, and 9, right? So basically we have 6 pairs of I comma j. That, okay, not 3 actually, my bad. Because 5 is not less than 3, so we cannot actually take 3. So we can actually only take 6 and 9. All right. So for all of these 5 pairs, so 1 comma 3, 1 comma 6, 1 comma 9, 5 comma 6, 5 comma 9. So we have 5 pairs, and we have to calculate the sum of 2 to the power pj minus pi minus 1. So calculate the sum of this thing. Now how do we do that? Basically, we can actually efficiently count. Now see, what we can just do is, for I equals to 1, just calculate it manually. Like for in O of n, just calculate this sum. All right. Like just calculate the sum of 2 raised to power pj. All right. So in this case, what is p? Let's calculate that. So this is the array A, right? And what about the array p? P is the prefix array of number of 2's, right? So it has 0, 2, then we have a 2, then we have no 2, then we have a 2 again, then we have no 2, then we have no 2, then we have a 2 again, and no 2, right? So this is the array p. Now, let's say we calculate 2 raised to power pj ka sum for these 3 indices. Okay, so let's say we calculate this sum of 2 to the power pj. So that is 2 to the power p3 plus 2 to the power p6 plus 2 to the power p9, right? So what is that? 2 to the power p3, what is it? P3 is 1. So 2 to the power 1, which is 2, plus 2 to the power p6, which is 2. So 4. And 2 to the power p9, which is 4. So 2 to the power 4 is 16, right? So this is 22. All right. So currently, what we have computed is that the sum of 2 to the power j or 2 to the power pj for j equal to 369 is 22, right? Now, for let's say for I equal to 1, we want to calculate the answer. What is the answer? Answer is just summation of 2 to the power pj minus pi, right? So actually, I can write this as summation, or okay, minus 1 also. Summation 2 to the power pj upon 2 to the power pi, right? And actually, we have the sum of 2 to the power pj, right? We have already calculated it. For j equal to 369, we have already calculated the sum of 2 to the power pj. So what we can actually do is we can write it like sum of 2 to the power pj divided by 2 to the power pi, right? Because this sum is for particular I. Like we are calculating this expression for a particular I. So therefore, I can write this entire thing as summation of 2 to the power pj upon 2 to the power pi. So, and we already know this value, right? We already know sum of 2 to the power pj. So let's say I have I equal to 1 and j equal to 369, right? So sum of 2 to the power pj I have already calculated 22. So let's say I want to calculate the sum of uh, 2 to the power pi minus pj minus 1. So I'll just first calculate this part. Like I'll ignore the minus 1 for now. So to calculate this, it is basically 2 to the sorry pj minus pi. My bad. So to calculate this, I can just do that the sum, that is 22 divided by 2 to the power pi. And what is pi? Like for I equal to 1, we are calculating, right? So what the pi is p of 1, which is 0. So 22 upon 2 to the power 0, right? So 22. So this is the sum of 2 to the power pj minus pi. But there was a minus 1 here as well, right? So to do that, like to handle for the minus 1, we can just subtract 3. Why 3? Because there were 3 different values of j, right? 3, 6 and 9. So 3 different values of j. So like basically what we had is 2 raised to power pj, or let's say p of 9 minus p of I, and minus 1 plus 2 to the power p of 6 minus p of I minus 1 plus 2 to the power p of 3 minus p of I minus 1. So basically we have total minus 3. The number of j's we have minus 3. So therefore I do minus 3. So we have 19 in this case. All right. So this was for I equals to 1, right? So what we just did, we calculated the sum for 2 to the power pj. So we calculated 2 to the power pj, like 2 to the power p3 plus 2 to the power p6 plus 2 to the power p9. And then we just divided it by 2 to the power pi, right? And then we did minus 3. So that's how we got our answer for I equal to 1. Like for all pairs I equal to 1, we got that answer. But why did we do that? Like did we do that? Because what we can just see here is that, see, what we did is we computed this 22, right? We calculated this 22 in O of n. So like we iterated over all the positions of j where a of j was equal to 3. We went over that and calculated this 22. But actually we don't need to do that again. Like what I'm saying is, for I equals to 5, suppose I want to find the sum. Again I want to find the sum for j equal to 6 and 9. But for that, what I can just do is, I can just remove this 3 from this. I can just remove this 3 from the sum. So I have already calculated that 22 is a sum. So to calculate the 6 and 9, to calculate the sum for the 6 and 9, I can just remove this 2 to the power p of 3. Like for 3, 6, 9, I know the sum is 22. And now I want the sum for 6 and 9. So I can just remove the 2 to the power p3. So what is 2 to the power p3? P3 is 1. So 2 to the power P3 is 2. So I'll just remove 2 from this 22. So for 6 and 9, like for j equal to 6 and 9, I get the sum as 20. Okay. So that's what I can do. And to calculate the final answer for I equal to 5, I'll just divide it by 2 to the power P of 5. So 20 divided by 2 to the power P of 5 and minus 2 I will do, because we have like 2 elements of j. So what we can just do it, we can also keep a counter. Like we'll keep 2 variables. One is sum and one is counter. So the sum actually stores is 22. So initially it is 22. Then we are iterating. Okay. So we are iterating, and while we are iterating, we'll just remove the j, where we have already, like, basically how to implement this I'll explain later. So see, right now what I'm explaining is that for I equal to 5 I want to calculate. For I equal to 3 we have calculated also. That for I equal to 3 we have 19 we have gotten, right? And for I equals to 5 we have j equal to 6 and 9. For that sum equals to 20, and we divided by 2 to the power p of I, and I is 5, so we divide by 2 to the power p of 5. So what is p of 5? P of 5 is 2, right? So we divide this 20 by 2 to the power 2, so which means 20 upon 4 minus 2, which is equal to 5 minus 2, which is equal to 3. Okay. So for I equals to 5, the answer is 3. And for I equals to 1, the answer is 19. So we can just add up these two answers and we'll get 22. So 19 plus 3, so which is equal to 22. And this is our final answer, 22. So that's how we can actually optimize our approach and just compute the sum of j. Like we'll just keep track of the sum of p of j. and to find an answer for a particular I, we'll just divide it by 2 to the power pi and minus the count of j. But then, so basically, I'll just explain again that how to exactly implement this. So I'll kind of dry run on this thing. Okay, 1 2 3 2 1 3 2 2 3. So the idea is to keep track of all the pj ka sum. So to keep track of 2 to the power pj ka sum. Okay, where a of j is equal to 3. So for all the indices j, where a of j equal to 3, I will keep track of the sum of 2 to the power p of j. So to do that, first of all, I'll just iterate in O of n over this entire array and calculate the sum of 2 to the power pj. Okay, so this was the array A. The array P is, sorry, 0, 1, 1, 2, 2, 2, 3, 4, and 4. And the index, let's say I just draw the index 1, 2, 3, 4, 5, 6, 7, 8, 9. So I start from I equals to 1. No, before that, I'll just calculate the sum for all the j, right? So I just calculate 2 raised to power pj का sum j equal to 1 to n, but also we have to ensure that a of j equal to 3. Okay, so we calculate this. So when we calculate this, we'll store it in a sum variable. So we have one variable called sum. Okay, 7, 8, 9. We have one variable called sum. So initially it contains, so basically it contains the sum of 2 to the power p of j. All right. So now when I'm iterating over the array, let's say I start from I equals to 1. I see that a of I is equal to 1, right? So that means that this is one possible I. Like over all the possible ij's, this is one possible I. So I will have to calculate the answer for this I. All right. So to do that, I can just do, okay, and initially also we have another variable called count. So count is equal to 3 right now. That there are 3 values of j. All right. So now I'm iterating over the array. So first index is 1 and a of 1 is equal to 1. So since it is 1, I equal to 1 is a possible value. So what we can do is we can add the answer for I equal to 1 into our ans variable. So initially ans equal to 0, we'll set ans equal to 0, sum equal to summation of 2 to the power pj, and count is equal to the number of indices. We'll maintain these 3 variables and iterate over the entire array. So since a equal to 1, I equal to 1 is possible. So to add the answer, I'll add answer plus equals the sum, which is sum of 2 to the power pj divided by 2 to the power p of I and minus count. So I'll do that if ai equals to 1, right? But now what if ai equals to 2? Or let's say ai equal to 3. ai equal to 3 means we actually have to remove this from the sum, because when we go ahead, like when we move ahead and we find a 1, let's say, we don't want to count this previous 3. So we will actually remove it from the sum. So when I'm iterating over the array, if ai equals to 1, then I'll increment the answer by sum minus, by sum upon 2 to the power pi minus count. If ai equal to 3, then I'll update the sum. I'll update the sum. What I'll do is I'll do sum minus equals 2 to the power p of I. Like basically ai equal to 3. So I'll decrement the sum by 2 to the power p of I. And also I'll do count minus minus. So let's say when I go to this 5 now. So basically when I was at 1, I incremented the answer by 19. Then I was at 2, I did nothing. Then I came at 3. So I decreased the 3. So I decreased the sum by 3 or by 2 to the power p of 3 to update the sum. Then I went to this fourth index, aj was 2, so I did nothing. Then on fifth index, this ai was 1. So I did sum upon 2 to the power p of I minus count. And to ensure that I don't count this 3 in in the sum variable, I just decremented that value in here. Like when I was iterating and I came across 3, I just removed the contribution of 3 from the sum variable. All right. So, and the finally, your answer is just ans variable. Okay. So that is actually the code only. So I'll just show you the code as well. Okay. So I'll just take the input int n cnn iaan, and I have a prefix array. So actually I define it like this, that p of 0 equal to 0 and p of 5 plus 1 equal to p of 5 plus a of 5. So essentially I am taking that p of I equal to a of 0, like 0 1 2 up to I minus 1. Like this is what I have defined as p of I. So p of I plus 1 equal to p of I plus a of I equal to 2. So I'm just counting the number of 2's. Now I have these 3 variables I have told you, that ans, sum and count. Sum is the sum of 2 to the power p of j, count is the number of j, and ans is my final answer. So p1 equal to 0. While p1 less than a of p1 is not equal to 1, p1 plus plus. So basically I am finding the first one, because I don't care about the occurrences before that, because the first one we have to take only. So while p1 less than n, a of p1 not equal to 1, p1 plus plus. If p1 equal to n, that means that there is no 1 in the array, so I'll just print 0. Now for ll I equal to p1, I less than I plus plus. So what I'm doing is I'm iterating from p1 to n. So if I'm basically finding the sum of 2 to the power pj in this. So if ai equal to 3, then I'll increment the sum by 2 to the power pj, or j plus 1, because I define it like that. Because I defined it like 0 to I minus 1, I'm doing 2 to the power j plus 1. Sum plus equals 2 to the power j plus 1 and count plus plus. So right now this is the initial sum, and then I just iterate from p1 to n. So if a of I equals to p1, then I increment the answer by sum into, so sum divided by 2 to the power pi. Sum divided by 2 to the power pi, and I'm just multiplying it by the modular inverse. So modular inverse is 2 to the power pi to the power mod minus 2, right? So that's the modular inverse. So what I'm just doing is I'm dividing it by 2 to the power pi and minus count. So sum plus answer plus equals sum divided by 2 to the power pi minus count. So that's what I do if a equals to 1. And if a equals to 3, then I just update sum in the count variables. So sum minus equals power 2 to the power pj plus 1 and count minus minus. And then I just print the answer. Right? So that's the solution to this. Then I'm just keeping track of the sum of pj, and to calculate the answer for interval I comma j, I can just divide the sum upon 2 to the power p of I. And since there's minus 1 also, we just do minus count, right? So that is the solution. Everyone, is it clear now? Clear. Okay. So I think I should move on to the next one. So we'll discuss the problem D now. Okay. Uh, yeah, the problem D. You are given a string S consisting of lowercase Latin letters. You can perform the following operation with the string S. Choose a contiguous substring of S and shuffle it. That is, reorder the characters in the substring as you wish. Recall that a palindrome is a string that reads the same way from the first character to the last, and from the last character to the first. Like the palindrome, what is palindrome? We know. Okay. Your task is to determine the minimum possible length of the substring on which of the aforementioned operation must be performed in order to convert the given string into a palindrome. So basically, you can select a substring and shuffle its index. So you are given a string, and in one operation, you can select a substring, and you can rearrange these characters however you like. Okay, and then you have to report the minimum possible length of this substring. Okay, so let's look at samples. All right, so let's look at this BA. BA. This is actually not a palindrome, right? So what we can just do is we can select these two. We can select this substring and shuffle it. Like we can rearrange it like this. That BA. So now it is a palindrome. So therefore the answer is 2 in this case. Okay. Then this CC is already palindrome. So the answer is 0. Then we have DDAA. DDAA, in that what we can do is, like definitely 2 is not possible. Because let's say we select these two, then it is not possible. If we select these two, then obviously it is not possible. And if we select these two, then it can become DA. But there is also not a palindrome, right? So ans equal to 2 is not possible, but we can select 3. If we select these 3, then it will become dad, right? So the answer is 3 for this test case. And for this one, the answer is 2. Why? Let's think about it. So we have, let's just copy this. Never mind. So we have ACBA CDD. ACBA CDD. ACBCA. Right? So we have this. So definitely this A and A are the same, C and C are same, B and B are same. Then like this substring is not a palindrome. So what we can do is just select these two and change their order. So it becomes CA, DD, AC. So now this is a palindrome. So therefore the answer is 2. All right. So actually, by seeing this sample, actually you might have gotten some idea of what we can do here. Okay, the first observation is that, like, okay, in this question, there are two observations. Okay, first one and second one. And actually, in contest, I knew the first one, but I couldn't figure out the second one. So therefore, I could not solve it in the contest. But now I know the solution to it. So I'll try to explain it. Okay. So the first observation is that you have to find the minimum possible length of the substring on which the following operation must be performed. So the minimum length, you have to find the minimum length, right? So minimum length means that let's say that it is L. The answer is L. Then by definition, minimum means that you cannot do it in L minus 1. You cannot do it with L minus 2. It is not possible to do it with L minus 2, L minus 1, and so on. But it is possible to do it with L, right? But also it is possible to do it with any other value like greater than greater than L. So L plus 1, L plus 2, and so on. It is possible to do it with these other also. Like if it is possible to do it with L, like basically there is a string and you choose a substring of L length L. Okay. So let's say L equal to 4 in this case, and you shuffle it, and you are able to make it into a palindrome, then definitely you can choose a length 5 as well. So if you choose this length 5 and you don't touch this character, you just shuffle these 4, then also it is possible that you make a palindrome. So therefore, if you can observe that all of the values less than the minimum, they will give answer as no, and greater than equal to the minimum, it is yes. So actually it follows kind of monotonicity, right? It follows something like 0 0 0 0 1 1. So this is kind of the pattern on length, that if we choose a length that is too small, then it is not possible. But after a certain threshold, it is always possible. So what we can do is we can just do a binary search on the answer. Binary search on the answer. Like we can try that. Okay, that let's say we have a certain mid element. Okay, so we'll check that is it possible to make this string a palindrome using this mid length or not, right? So basically we want to do the operation using this mid length and figure it out that is it possible to make this string s into a palindrome or not. Okay, so how do we do that? So let's say we had this test case. Okay, I'll just copy that test case. Okay, someone did not understand the monotonicity part. I'll try to do it again. I'll try to explain it again. So basically, what I'm saying is, let's say that the minimum length that you can do the operation on, like this is a string, right? Let's say the minimum length that you have to do is 4. Okay. And let's say this is the operation. So see, I am saying that these two are already equal, these two are already equal, and there is a C here. And let's say there is a C here, a D here, um, C, D, E, and D, let's say. So definitely you would have to like rearrange this palindrome. Like you have to rearrange this subarray into what? Into D, E, D, and C. So it would become like this. So therefore the answer is 4. Like using this 4 length of subarray, you can rearrange it and you can find the answer. Like you can make it into a palindrome. But my claim is that for any length greater than 4 also, if you choose any length greater than 4, you can do it. Why not? Because what you can just do it, suppose you want to choose a length 5. Okay. So then just choose like initial for 4 you choose this, right? So for 5 just choose this. For 5 just choose this and don't touch this C. Like you have it's in your hands, right? You can choose not to rearrange an element also. So just don't rearrange this C, just rearrange all of these 4 letters the way you did in 4. So that's why you can select a substring of 5, rearrange it, and it is possible to rearrange into a palindrome also. So that's why it is monotonic. So did you get that now? Okay. So that's why we can do a BS on an answer, right? So how do we do that? We can do it simply by just observation. Okay, so that was the first observation, but that binary search we can do, or basically monotonicity. Monotonicity. All right, that was the first observation, and the second observation is that I'll explain right now. Okay, so I'll paste it right here. Yeah, so we have like this. We have this string, right? Now let's say I want to figure out whether I can do it with L equal to 5 or not. Okay. So first of all, it is very obvious that the letters which are matching. So let's say this A and A are matching. Then this C and C are also matching. Then this B and B are also matching. So you would never touch them, right? Why? Why in the world would you ever touch them? You would never touch them, right? So just separate them, like keep them in a box or something. So just separate them, just ignore them for now. And basically, we want that this substring should be a palindrome, right? So what we have observed is that till wherever the letters are equal, we won't touch them, obviously. So we'll just ignore them, and the remaining portion we want to make a palindrome, right? Now, since we have already ignored all of the possible characters that we can ignore, then that means that this first letter and this last letter are actually not equal, right? Because if they were equal, then we would ignore them as well. but they are not equal, right? So now we have a new string in which the first and last characters are not equal, right? So if you do an operation on anything that is not containing both this and this, like suppose you do an operation, let's say L equal to 2, and you do an operation on this thing, okay, then definitely I can say that it is not a palindrome because this A and C are not same. Like initially, the first and last character is not the same. Last is not equal to first, right? And if you don't choose a substring which has either of these two, that is, you don't choose a prefix or a suffix. So see, any prefix you choose will contain a, right? So if you choose any prefix, then it will definitely contain a, right? Let's say you choose the prefix length 4, then it will contain a. And if you choose a suffix, then it will contain c, definitely. But if you don't choose either a prefix or a suffix, then it won't contain either of a and c. It won't contain a and c, and therefore they can never be equal. Like these two positions can never be equal, and therefore the string will not be a palindrome, right? So for a certain length, you will always check either the prefix or the suffix. That's what my point is. That let's say we want to check mid equal to 3, or let's say mid equal to 3. You need to check that is it possible to rearrange the string. Can I explain that part again? Okay. What I'm trying to say is that in the original string had some more characters, right? In the test case, like the original string was this, that ACB, ACDD, ACBCA. But now, obviously, we will never, like already is A and A are equal, C and C are equal, B and D are equal. So we'll definitely won't touch them. So we'll just ignore them for now, right? Because they are already a palindrome. Already they are forming a palindrome. So the remaining portion, we will try to make a palindrome. So if we just make this a palindrome, then definitely the entire string will be a palindrome, right? So now we have a new string, right? We have a new string in which the first character and the last character are not equal. First character is not equal to last character, right? Because if they were equal, then we would ignore them as well, right? We would just include them in the deleted portion. Okay. So what I'm saying is that if we do not rearrange them, like the operation that we can do is we can select a substring, right? We can select a substring and we can rearrange it. But if we do not choose either of these two, like if we do not rearrange them, then definitely here A will be there and here C will be there. Like if I choose a substring which is not a prefix or a suffix, let's say I choose this, then definitely A will be remaining here only and C will be remaining here only. So my point is that you always have to either choose A or either choose C. Like you cannot do that, you don't choose any of them. So if you choose A in a substring, then that means it is a prefix, right? And if you choose C in a substring, that means that it is a suffix of the string. So you have two options, that either the prefix or the suffix only, right? That's my point. That either you choose a suffix or a prefix. So now what you want to check, that is it possible for the length mid, like for a length equal to mid, let's say mid equals to 3. So is it possible to rearrange them using like choosing 3 length? So I have two options, that either I can choose a prefix or a suffix, and length is also fixed. Like the length is also fixed. So that means the prefix that means there are only two options. That either I can choose this 3 length prefix ACD to rearrange, or I can choose this DAC to rearrange. So I'll just check both of them. That can I rearrange them and make it a palindrome? And if either of them the answer is yes, then definitely my actual answer is less than or equal to mid. Like I'll just set high equals to mid in my binary search, and otherwise I'll set low equals to mid plus 1. All right. So basically now what remains to check is that how do we determine that is it possible to make it a palindrome? Like we have been given a string ACD let's say, or let's take a better example, or let's just take this ACD, and we need to figure out that can we choose, like if we choose a length 3 prefix, then is it possible to make it a palindrome? So, or in general, if we can say, in general, if we have a string, and let's say we choose a prefix of this, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's say the length is even, okay, the length of the string is even, so it has a midpoint. So this is the midpoint, and we want that the string should be a mirror image around this midpoint, right? And what we can do is we can rearrange these 3 elements, let's say. Like basically we want to figure out that is it possible to rearrange these 3 elements and to get a palindrome, right? So to check that, basically the first thing to check that these two should be equal and these two should be equal, right? That is pretty obvious. So once that is out of the way, what we can check is that that these three characters and these 3 characters should be the same. Like in any order they can be, but they have to be the same, right? So we can just rearrange this according to our wish. So let's say we had BCA here, BAC here, and let's say CBA here. So we can rearrange this and make it ABC. So that's how we check. So first we need to check that these 2 elements should be equal and these should be equal. And then we just check that these 3 and these 3 should be equal. Like not their order, but they should be equal. So we just need to check that frequency map of prefix of length mid is same as frequency of suffix of length mid. Yeah, that thing ensures this. But you also need to ensure that these two are same and these two are same. Like because you cannot change these characters, right? So that's what you also need to observe. That's what you also need to check. That okay, from mid plus 1 to n minus mid, it should be a palindrome already because you cannot change that. Okay, that's how. But actually, there is one caveat here. That what if the length of this prefix is greater than n by 2? So let's say we have 5 here, 4, 5, 1, 2, 3, 4, 5, and let's say the prefix length is 6. That basically, or let's say 7. So we can change the order of these characters. So then how do we do that? Like how do we check? Then basically we can just make a multi-set, right? Like just make a multi-set of these characters and iterate in reverse. Like let's say there's a here, then that means that there should be an A in this multi-set. There should be an A in this multi-set, and we'll insert that A here. And then we'll delete that A from the multi-set. Then let's say we have A here again. So there should be another A in the multi-set, and we'll put that A here. And so on, we can check like that. So we have 2 cases, that is mid less than n by 2. Like if mid is less than or equal to n by 2, or mid is greater than n by 2. So both cases we can check. And actually we can just use this method in the above one as well. Like let's say if we had 4, 5, 6, 7, 8, 9, 10. Let's say we had 3 length. Let's say mid is equal to 3. Then we can just make a multiset of this and iterate through these three. So let's say there is a here, a B here, and a B here. So what we'll do is make a multiset of these three elements and iterate in reverse from this. So first we check A. A should be there in this element. So I'll put A here and delete A from the multiset. Then B should be there, so I'll put a B here, and another B should be there, so I'll just put a B here. That's what you can do in both the cases. And but you need also to check that if mid is less than n by 2, then also you need to check these characters as well, that they should be equal. Like suppose there's a B here and a D here, then they can never be equal because we are not rearranging these characters. We are only rearranging the prefix. So that's how you check a prefix. And to check a suffix, it is pretty easy. Like you can just reverse the string and just check the prefix. Like just write a function to check a prefix and call that function for that string and for the reverse of the string as well. That's what I did. Like if I show you the code, I have a check function which basically checks for me that is it possible using this mid. So int n equals to s dot size. So first I'll check from mid to n by 2 that si should be equal to s of n minus I minus 1. Like this in this case, that when mid is less than n by 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When mid is less than n by 2, I just need to check that these two elements and these two elements should be equal. Right? So from I equals to mid, I less than n by 2, I plus plus. If s of I is not equal to s of n minus I minus 1, return false. Okay. Then I have a multiset of character ms1, ms2. Actually, I just use ms1 here. Ignore this ms2. Just ignore this ms2. From I equal to 0 to mid, I inserted ms1 like for the prefix mid. So I inserted these three characters into the ms1. Then I just iterated from the back that I equal to n minus 1, I greater than equal to n minus mid, I minus minus. And also I greater than equal to mid also. So basically, let's say if this was the case that mid is greater than n by 2, then it will stop here only. It won't go till 7. It will stop at 3 only, because if till 3 it is satisfied, then obviously till 7 it will satisfy. Okay. So I equal I equal to n minus 1, I greater than equal to mid, and n minus mid, I minus minus. If ms1 dot find is not equal to ms1 dot in, so if ms1 has s of I, then I will erase it from ms1, and otherwise I return false because there is no corresponding element here. So if there's an a here, but there is no a in these three elements, then that means that it is not possible to make it a palindrome, right? So I will return false. So that's how my check function works. This is same as maintaining frequency map, right? Yes, it is the same. You can just maintain a frequency map or a multiset. They both are same. And yeah, this is the actual code of binary search, that I take the input of S, right? And I make a new string called T. So T is the string S where the first few characters and last few characters are the same. They have been truncated off. So I have a pointer P1 equal to 0. So while P1 less than N, and if S of P1 is not equal to S of N minus 1 minus P1, break, and else P1 plus plus. So what I'm doing is I'm just iterating till it is a palindrome. And if P1 equals to N, that means that the whole string is a palindrome, so I'll see out 0. Then from I equal to P1, I less than N minus P1, I plus plus, T plus equals S of I. So T is basically the substring that after removing this ABC and CBA, like T is basically this string that after removing this ACB and BCA, T is this. Okay. And also Like, okay, basically I am storing two strings that I just set s equal to t, and also I reverse t dot begin t dot end. So at this point, s is a string which has all its character removed, the palindromic character removed, and t is a string which is reverse of s. Okay. Then I just iterate over like the binary search, low equal to 0, high equal to n. While low less than I, mid is equal to low plus high by 2. So if check s of mid, so basically this checks a prefix, or check the reverse of s. So t is reverse of s. So if check t comma mid, so if either of these two is true, then I'll just do high equals to mid. Otherwise, low equals to mid minus low. And then I just print low. So this is the simple binary search code. So yeah, summarizing, we can basically do binary search answer. And once we eliminate the first few and the last few characters, we can be sure that either we have to make the operation on a prefix or on a suffix. So we can just do BS on that, BS on length, and just check that is it possible to do it using that length on either a prefix or a suffix. Okay, so that was the solution for that. So do you all have a doubt? Any doubts, anyone? Can I explain check function again? Okay, so what I am just doing is, let's say I have a mid, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have this mid. Okay. So from I equal to 0 to mid, or 0 to mid minus 1, I am inserting it in a multiset. ms dot insert. Okay. And then I'm iterating from the back. That last three elements, I'm iterating. So see, I have inserted these three on the multiset, and from the back I'm iterating. So what I have done is I am checking that this should be the multiset, and if it is, then I'll decrease the frequency of that. Then it's checking that they should be in the multiset, and then they should be in the multiset, and then I'll end my comparison, and also I'll check that these two should be equal and these two should be equal. So that's the case when mid is less than n by 2. But if mid is greater than n by 2, like if the case is something like this, 5, 6, 7, 8, 9, 10, that the mid is like this, then actually what I'm doing is I'm just checking the last three characters. Like I'm inserting all of these seven into the multiset, but I'm only checking the last three. So this should be in the multiset, this should be in the multiset, and this should be in the multiset. And if I reach here, then I just break. So that's what I'm doing in the code. In the code, I'm doing that initially I'm checking from, like, okay, first I'm checking this condition that these two should be equal and these two should be equal. So from I equal to mid, I is an n by 2, I plus plus. If s of I is not equal to s of m as 1 minus I, return false. So I think this should be clear. And yeah, if mid is greater than n by 2, then obviously this loop won't even run. Because if mid is greater than n by 2, then it won't run. So it doesn't matter. And then first mid characters I put into a multiset. And then from the reverse I iterate. So if mid is less than n by 2, I just iterate through the last mid. And if mid is greater than n by 2, I iterate to the last n minus mid. So while I equal to n minus 1, I greater than equal to mid, and I greater than n minus mid, I minus minus. And I just I ensure that it is in the multiset of this one. So like where exactly have you a doubt in this? Okay, clear now. Good. So I hope no one has a doubt. So if you guys don't have a doubt and any questions, then I will end the meet. So do you guys have any doubt in other questions also, like A, B, C, or D, or any general doubts or something? about the contest? No. Okay. All right, then I'll take your leave. So I'll end this meeting now. Expected rating of D? It is. I think it is pretty easy for D. Like it should be, I think, Sora 1600 or something. Let's check. It is okay. It is 1800, 1900 again. But I think this is pretty overrated. Like, it is pretty simple, I guess. Like the only observation you have to make, and then it is pretty simple. But yeah, it is 1800 as said by CF. Okay. So yeah, let's end the meet now.